Hello, everybody. We are going to discuss some long division, some synthetic division, and kind of the definition of what a factor is. So that's the goal for today. So I want to I have a division problem here. I'm going to do it both with long division and synthetic division. And I want to make sure you guys can perform this operation, both methods. Okay, so I'm going to kind of title at the top here. If I have long division, we'll do that on the left, and then we'll do synthetic division on the right. All right, now, one thing that you should know, what allows me to do both is you can do long division for any problem. Any division problem you can use long division on. Synthetic division you can only use when you're dividing by x plus or minus a number, okay? If it was like 2x or 3x in front, then we couldn't use synthetic division anymore. And it's just more of a hassle than it's worth. So we're going to take advantage of both for this problem, but you'll see in some future problems we'll have to use one method or the other. So for long division, I'm going to put my 2x cubed minus x squared minus 6x minus 1, and then my x plus 1 on the outside. Okay? Now, the way I start my long division is I want to figure out what do I need to multiply x by to get a 2x cubed, right? So I need to multiply x by a 2x squared in order to turn it into a 2x cubed. So 2x, now I take this number on the top and I'm going to distribute it to both terms. So 2x squared times x is a 2x cubed. 2x squared times 1 is a 2x squared. And then I am going to subtract. Okay, now here's where you have to be very, very careful. Okay, I like to, on the very top, I have a negative 1x squared minus 2x squared, and that is going to give me a negative 3. If you're going to make a mistake, 9 times out of 10, it's on that subtraction. So a negative 1 minus 2, right? And that would give me a negative 3x squared. All right, so that's the first step. So now I want to just repeat that process. I'm going to bring down the next term and do everything the same way. Okay, so here's how it works. I'm going to take that first term, that x again. What do I need to multiply x by in order to turn it into a 3x squared or a negative 3x squared? Well, I need to multiply it by a negative 3x. So negative 3x times x is a negative 3x squared. Negative 3 times 1 is a negative 3x. Put my subtractions in right away. Again, these first terms, since they're the same, will cancel. And I like to off to the top here or off to the side. I like to do my subtraction just so I don't make any mistakes. I have a negative 6x minus a negative 3. Now, if you subtract a negative, so I have this negative 6, nothing happens to that. But in the middle, you can see I have this minus minus, or this minus and negative. So in that case, whenever you subtract a negative, that's just a plus, and that gives me a negative 3x, okay, on the bottom there. So that was step number 2. So we're going to do it one more time because we got one more term to drop down. And I'm going to repeat the whole process. So I want this negative 3x to match this x, which means I want to multiply by a negative 3. So if I do that, I get a negative 3x. Negative 3 times 1 is a negative 3. I'm going to put my subtractions in, and those cancel. So now I'm going to, again, I like to do my subtraction off to the top or off to the side. Make sure everything looks good. So I have a negative 1 minus a negative 3. So it looks, I have a negative 1 and then that minus minus, or subtracting the negative, it's going to be plus 3. Negative 1 plus 3 is 2. So that is my remainder. So my answer here is going to be a 2x squared minus 3x minus 3. And then my remainder is 2 over what I divided by. and that gives me my answer. Okay? So now I want to do the exact same problem with synthetic division, and I like to do this in 2 steps. So step 1, we are going to set the denominator equal to 0. Okay, so the denominator in our problem was an x plus 1. We're going to set that equal to 0. Okay, I'm going to solve that, and I get x to equal a negative 1. All right, now you're probably wondering, well, what do we do with that? Okay, step 2, watch how I do this. We're going to set up synthetic division. All right, and to set up synthetic division, I draw this like big L, okay? Now on the outside goes this number, okay? This negative 1, all right? On the inside, I want you to look at the numerator here. Look at the original problem that we are, that we're dividing. I'm going to take all the coefficients and I'm going to put them in a row on the top of this L. So here's what it looks like. So I'm going to take those coefficients. I'm going to do them in blue. So the first coefficient was a 2. No x's needed. The next coefficient was a negative 1 that I highlighted. The next coefficient was a negative 6 that I highlighted. Last one was a 1, negative 1, right? So I write them on the top. Now, pay very close attention. Feel free to pause, rewind as needed here, but I want to show you how synthetic division works. I'm going to drop the 2 straight down. We don't do anything to the 2. It just falls. That's the first number on the bottom. Then I'm going to take this negative 1 on the outside, and we are going to multiply negative 1 by 2, and I write that number right underneath here. So negative 1 times 2 is a negative 2, and then I'm going to add straight down. Negative 1 plus negative 2 is a negative 3. And ladies and gentlemen, I'm going to do that again. So negative 1 times negative 3 is 3. And then I add straight down. Negative 6 plus 3 is a negative 3. And then, ladies and gentlemen, one more time. Negative 1 times negative 3 is a positive 3. Add straight down. And I put a box around this last number because that last number is my remainder. Now, we started with a cubic function. If you look at that original problem in white, that was a cubic function. We divided it by a linear function, which means it's got to get smaller, right? So if we take a cubic and we divide it by a linear, what's going to happen here is we are going to get a quadratic. So see these numbers that are on the bottom here? Well, we know the last number is our remainder. But watch what I do here. Because it was cubic, it's going to get smaller. So now it's going to be squared. Minus 3x minus 3 plus my remainder. You see how I just put my x's back in there? I started with quadratic, and then each term goes down a degree. Look at these 2 answers. It looks like magic. It's not. It's just synthetic division. Okay, we get the same answer either way. So the purpose of this video is going to be to talk about factors and to talk about synthetic division. Okay, there is a previous video that goes through long division, so if you want to practice that, there is a video for that. But to keep the video short, we're going to use synthetic division for most of the problems today. Okay, so the other idea is the idea of a factor. So what does it mean to be a factor, right? A factor of 30. I could have 2 is a factor of 30. 5 is a factor of 30. 10, 15, these are all 3. These are all factors of 30. And the reason is because they can divide into 30. And most students tell me the word evenly, right? They divide into it evenly. But I want to really iron down what that means. What does it mean to divide into the number 30 evenly? Okay, so a factor is when you divide you get a remainder of 0, right? So if you divide 30 by 3, you get 10. No remainder, it's just 10. So therefore, 3 is a factor of 30, right? If I were to take 30 and divide it by 7, well, that's not going to come out so nice. That's going to give me a remainder. When you divide that out, you're going to get a remainder or a decimal at the end, and that ultimately tells me 7 would not be a factor of 30. Okay, so you have to have a remainder of 0. Now, we're going to apply that to these problems that we're doing. So if you take a look, x plus 1, based off of what we're seeing, is not a factor of that polynomial. How do I know that? Well, because I got a remainder of 2, right? It didn't matter which method of division I chose. I got a remainder of 2. So because there was a remainder, I know it was not a factor. And you're going to see me do that for some examples coming up. So take a look at this one. Now, I'm going to utilize synthetic division here. I want to show you how it works. I also want to identify at the end, is this or is this not a factor? So I'm going to start step 1. Set the denominator equal to 0. So I'm going to take that x plus 3. I'm going to set it equal to 0, and I want to solve it. So I get x equals negative 3. Okay? Then I'm going to set up, step 2 is I set up this synthetic division, and that negative 3 goes to the outside. Okay? Now, we have to look back at the original problem. We want the numbers that are in front. So if there's no number there, right? So if I just have x cubed, there's like a 1 there. Negative 3, negative 17, and 3, right? So those are the numbers that are going to go on the top row of my synthetic division. Okay? And what I'm going to do is I drop the first number down. Don't touch it. Don't do anything with it. Just drop it straight down to the bottom. And now I start my process. So negative 3, we multiply. Always multiply. Negative 3 times 1 is a negative 3. And then we're going to add straight down. That gives me a negative 6. Negative 3 times negative 6 is 18. We're going to add straight down. We get 1. Negative 3 times 1 is negative 3. We're going to add straight down. That gives me 0. So when I divide this, I'm going to get a 1x squared minus 6x plus 1, and then my remainder is 0, right? Now, when your remainder is 0, you don't really need to write that fraction, but ultimately, we do know not only can you tell me what you get when you divide it, but you can also tell me the other part. You can say that x plus 3 is a factor of x cubed minus 3x squared minus 17x plus 3. And how do you know that? Well, I know that because I got a remainder of 0, right? So whenever you get a remainder of 0, you know that that expression has to be a factor of that problem in front of it. Okay? So 2 parts to these questions. 1, can you divide it and tell me the answer? And then 2, can you tell me if it is or is not a factor? Okay? I'm going to skip ahead. I want to do another one just like it. All right? So let's see if we can do this. So I'm going to do it with synthetic division again. So step 1, set the denominator equal to 0. Right? So I have an x plus 9 is equal to 0. We're going to subtract the 9. Now, when I set up my synthetic division here, I put my negative 9 on the outside. I put the coefficients, so I have a 1, and then a 10, and then a 13, and then a 36. So look back at the original problem. You can see where I'm getting these numbers from. So I had a 1, a 10, a 13, a 36. So if I drop this 1 down, negative 9 times 1 is a negative 9. Add, I get 1. Negative 9 times 1 is a negative 9. Add, I get 4. Negative 9 times 4 is a negative 36. Add, I get 0. So ladies and gentlemen, my answer would be a 1x squared plus 1x plus 4, and then I get a 0 over x plus 9. So this is the first part. So this would be my answer after I divide. But the other thing is, can you tell me, is x plus 9 a factor of that polynomial? And the answer would be yes. Okay? X plus 9 is a factor because the remainder was 0, right? So I want to make sure not only can you still do the division. Now, you could have done long division for this. There's no harm in that. I'm just using this video to review synthetic division and also this idea of is it or is it not a factor, okay? One more time, okay, just for practice. Again, feel free to rewind as necessary. So I'm going to do this with synthetic division. We're going to take that denominator. We're going to set it equal to 0. I'm going to solve it, which gives me an x equals 3. Okay, I'm going to set up my synthetic division. I put a 3 on the outside. On the inside, I'm going to put all the coefficients for the original problem. Okay, now when I do this, I'm going to drop the 1 down, take this 3 and multiply it. Gives me 3. When I add, I get a negative 9. So now I want to take this 3 on the outside and multiply it into the negative 9. That gives me a negative 27. Add, that will give me 5. 3 times 5 is 15. Guess what, guys? I got another remainder of 0. That does mean it's a factor, but let's not get ahead of ourselves. I know the answer from the division is 1x squared minus 9x plus 5, and then my remainder, okay, is 0. And I can say x minus 3 is a factor of x cubed minus 12x squared plus 32x minus 15, right? Because the remainder is 0. So I do want you to know why. You have to tell me how you know it's a remainder, okay? All right. Now, here's the last one that I want to go through. Again, with synthetic division, that's the purpose of this video here. But we do have to watch out for something because we are missing a term, okay? There is a 0x in there. We have no x terms. So I'm going to do everything the same. I'm going to take that denominator. I'm going to set it equal to 0. If I solve it, I get x to be 3. All right. Now, when I set up my synthetic division, I have a 1x cubed. I have a negative 2x squared. I had no x's, so you have to put a placeholder. It is not an option. You can't like do it for some and not for others. If you are missing a term, you have to put a placeholder. That is not optional. And we're going to put that 3 on the outside. So if I do my synthetic division, 3 times 1 is 3. Add straight down. 3 times 1 is 3. Add straight down. 3 times 3 is 9. Add straight down. I get a remainder of 5. So when I divide this, I get a 1x squared plus 1x plus 3 plus 5 over x minus 3. Now, as you can see, we got a remainder that is not 0. So I would say x minus 3 is not a factor of that cubic polynomial. Okay? Hopefully this video helped with synthetic division and the concept of identifying a factor versus not a factor. Okay? Email me if you need anything. Otherwise, have a wonderful day.